We will start in 5 minutes. I believe this is a little bit odd time to join the lectures, but had I not taken the lectures on Saturday and Sunday, then we would have to have extra lectures on other weekdays. So that was the reason behind considering the classes on Saturday and Sunday. So we'll start the tutorial. It's 2:35. Today we are going for a tutorial, and tutorial means there would be input from your side as well. This is not just a one-way talk, and we would be having input as well as you will be required to do some work as well. So usually we are supposed to have around 6 hours of tutorial, and what I plan to do is we'll be trying to implement a particular algorithm. So, let us start with it. I have got a couple of around 15 slides, and then you will be required to work around the data and get the output. So today we'll be working on. Second, am I audible?
Yes, Dr. Altaf.
Yes, sir.
Yeah, thank you. So I'll just move ahead. This is the actually. I believe you all would be surprised to see a reference paper as the first slide. But today we are going to implement this particular paper. Here, we means actually you. I'll be providing the data, but you are supposed to implement it. So be ready to go, and we would be trying to implement this paper, right? Now, usually, whenever we talk of implementing a research paper as it usually takes around 6 to 7 months to implement that paper. This particular paper was written by me and Dr. Sanjari. He's from Griffith University, Australia. So we have got 2 hours to implement it. So obviously we will not be able to implement it in total, but let us try and implement it to the level possible. And then this particular paper was published in International Transactions on Electrical Energy Systems, which is a SCI listed journal by Willy, and the acceptance date was 26th May 2020. So that means it is not an old paper. Now, what are we going to go through is first we will try to understand some terms related to battery operation possible. Then we would try to, we are not going to go into the detail of the terms related to battery operation, but just the terms that may be required for us to implement it. Then study the relation between efficiency and charging discharging behavior of a battery. Now, this is the crux of the paper basically, as to when a particular battery should charge and when should it discharge. And based on the efficiency of the battery, we will decide when it should charge or discharge. Usually, whenever you will study uh, energy storage system in a smart home or any place, it is always coupled with the renewable energy which is available. But in this case, we are not talking at all about the renewable energy. Instead, we are just concentrating on the charging and the discharging behavior of the battery based on the efficiency of the battery. So, when should it charge? When should it discharge? Based on the efficient behavior of the battery itself. So that is where the crux lies of this particular paper. And then we'll study the available and the data that is required. And then we will try and implement it through a program if it is possible. But this has to be done by you, right? I'll not be sharing the code of it, but I'll be waiting for you to at least develop some algorithm or some flowchart based on the data which is available. Now, as far as I am considered, or I think so many of you all who have worked on research papers and all of it, usually whenever we study any paper, I usually divide it into three parts. One is what is an input, what is the input for the paper. Second, what are the results, what is the output of the paper. And the third is the process. And above all of it comes up the objective of the paper. Or the objective of the paper is very much clear when you study the title of the paper and when you study the abstract of the paper, right? Input is usually visible when we try and understand the results section of a paper. We do get to know what kind of input has been given to the system. Now, this input can be constraints, can be voltages, can be tariff, can be many other things. Output is usually costing, saving in costs, improvement in efficiency, improvement in reliability, changes in stability, and many other things. And then comes up a process. Process may be based on some AI technique, process may be based on some optimization technique. And yeah, Fabia, please. Fabia, you raised the hand. Hello. So there are different kinds of process. It may be an SVM process. It may be your own, expert system design that you might have gone for. So in this case, this is also a specific process that we are going to apply. So whenever we go through a paper, usually the abstract and the title will give you the direction in which the research has been performed in that particular research paper. And then for the output, we'll go to the result sections at the end or maybe through the conclusion to get the analysis as to what has happened. And process is clearly mentioned usually in a different section. And if there are multiple processes, comparison is there, then in that paper, in the results or just before the results, we'll find all these things. Now, this techniques or the process that we say is usually explained through flowcharts, algorithms, pseudocode, and all of it. As far as my analysis goes, usually the input, understanding the input in the paper is the most tough part. There are two reasons to you know target the input as one of the most toughest part in a paper. First, usually you don't get the full data that is required to implement that particular data. And the second thing is that sometimes the data is very hard to track down as to which data has to be taken up as the input for a given system. So many a times whenever you read a research article, you have to do reverse engineering to understand what values or what variables shall be required to be the input for the process and to obtain the output. And then even if you uh, you know get the data also, the checking of the data, the validity of the data also plays a very important part. Usually what happens is you get the data and then it is not valid enough, it is not correct enough, and then you waste a lot of time validating it. So at least in this paper, I'll try and provide you the data, but these are the problems that we usually face. In fact, during one of my own research paper analysis, I was using one of the standard IEEE standard system, but the source that I took was incorrect, and I did not know that I have taken a wrong source. And in that, what happened is that the impedance of one line was interchanged with the other line, and no matter how many times I check the algorithm and no matter how many times I check the program, I got the wrong answer all through and through. Until unless, and that was one of my first papers that I tried to implement. So until unless at one point of time I thought that maybe the system itself is wrong. And then when I went back and checked it from another source, I came to know that the data had been interchanged. So these kinds of problems will always come in. So today I will try to perform this all of this activity, identifying the input, identifying the process and output in a very fast manner of around 2 hours maximum. So I believe that since we have PG students, research scholars, faculties, industry personnel, uh, and all of them are not from electrical background, so I'll try and make this as easy as possible for you to understand. Now, these are some of the basic definitions related to battery, specifically that may be used in this particular paper. Depth of discharge will not be used, but it is another way of representing state of charge. So we have got charging efficiency. Can somebody just unmute and tell me what do we mean by charging efficiency? Anybody? Charging efficiency of a battery. Okay. So usually what happens is that whenever we go for charging of a battery, we may supply maybe 10 kilowatt, but the increase in charge of the battery is not 10 kilowatt. There are some losses that will always happen. So that is why we take up the charging efficiency. We may supply power to the battery, but it is not charged with the amount of charge that we have supplied with. So the deficiency in the charge, the reduction in the charge which is there, will be represented through the charging efficiency. On the other hand, sometimes the battery may discharge by 10 kilowatt, but on the output we don't get 10 kilowatt as the output. So this loss is considered into the discharging efficiency part. Okay, so discharging, again, we do not get as much of power as we have sent, and then comes up something called as round efficiency. So when we talk of round efficiency, what happens is we are trying to charge and discharge a battery. So what is the total efficiency in the whole process when we combine charging as well as discharging? So what is the total efficiency of the battery? That is called as round efficiency. So in this, what happens is, suppose if I have given 100 kilowatt as input to a particular battery, what do I get in return for it out of that 100 kilowatt? What was charged and what was discharged has to be considered into it. And by that, I'll try to understand what was the round efficiency of the battery. Then comes up charging rate. I hope I am clear. If you do not understand anything, just let me know. Okay? So this is called as round efficiency. In round efficiency, what I have given and what I get back, the ratio of that is called as the round efficiency. And in practical situation, we should be 100% sure that whatever I input into the battery will not be available to me as the output. It will always get reduced, right? Then there is something called as charging rate and discharging rate. So when we talk of charging rate, it is the rate at which your battery gets charged. Suppose if I've got a mobile battery in which they say that it gets charged in 2 hours, suppose. So what is the total capacity of my battery? Suppose if we say that it is like 5 watt, 5 kilowatt, no, 5 kilowatt would be too much. Let us say it is around 50 watt, just for the sake of it. So when it takes 2 hours to charge, that means it is charging by 25 watt per hour. So that is your charging rate. This will vary from the battery type and all of it. What kind of a battery you are using and other things also. Many other factors would be there. We will not go into the details of that today. And then there is something called as discharging rate as well. So in discharging rate, the same thing applies as to how fast I can discharge the battery. Usually, we would want the battery to discharge while taking a longer duration, right? You might have heard of supercapacitors also. You might have heard of capacitors also. Capacitors are not used for storing of charge. Why? Because of this same reason. The discharge rate is too fast. So, at what speed is it going to discharge? Then you have got a state of charge also. I believe whoever has studied about battery should be knowing about this thing. State of charge gives me the percentage of charge available in comparison to the total charge that can be stored. If the capacity of the battery is like, suppose if we say 100 kilowatt and right now it is charged with 50 kilowatt, we'll say the state of the charge is 0.5. If it is charged to 30% of the total charge, we'll say it is 0.3. So the state of charge will usually move from 0 to 1. When I say 0, that means it is fully discharged. When I say 1, it means it is fully charged. It will not take further charge into it. Now, usually what happens is whenever we are studying battery, and that day also I had asked a question to Professor Jahangir that the state of charge in his example for say, the electric vehicle charging in a mall, the state of charge when the vehicles were leaving in some cases was 100 or 1. So usually whenever you go through different research papers, you will find out that the state of charge is considered to hover around zero point 0.2 to zero point 0.9. The battery will should not be discharged below zero point 0.2 and should not be charged above 0.9% of its capacity. That is state of charge. Anyways, we'll go for it. And depth of discharge is another way of representing the state of charge itself. And then comes up the most important part, that is the time of use tariff. So this we'll go through in the later slides. Time of use tariff is the tariff that you pay according to the use of your load and at what time you are using it. So that is how it is combined. Then let us move to the next part of this. That is, what is the concept? The concept is to establish a relationship between battery round efficiency and the tariff. So again, I'll repeat for those who have joined in late that we are not talking about renewables today, but what we are talking about is when the battery should be charged and when should it be discharged based on the concept of round efficiency and tariff, the relationship between the round efficiency of the battery and the tariff. This was actually proved in another paper by Dr. Sanjari in one of his earlier paper, and in this paper we are trying to implement it. So here again, round efficiency is visible. How do we calculate round efficiency? Usually, as I said, if I have given 100 watt and what is the output is what I am going to take up as the round efficiency. So let us assume that suppose if I have supplied 100 watts to a battery and when it gets charged, we find that it is only 98 watt. That means 2 watts are lost in charging the battery. And when I try to use the battery, I find that I am able to only utilize it up to 95 watts. So then in this case, we would say that the round efficiency of the battery is 95% or 0.95, right? So we can find the discharging efficiency in this way and the charging efficiency in this way as well. But anyways, we are more interested into the round efficiency part. Now, round efficiency is usually the product of charging and discharging efficiency. Just go to that part here. And what we can see here is that the charging efficiency in this case, in this today's presentation, we would be taking the charging efficiency as 0.98. The discharging efficiency will take it as 0.9694. If you multiply both of them, you will find that the round efficiency comes out to be 0.95. So this is on the higher side only. Right? You can go for a practical battery, but the practical battery in the initial time may give you better results, but as it starts to go down with age, the round efficiency will also go down. Now let us come to that part called as tariff, and then I'll again give one more slide dedicated to the tariff part. Let us just one second. Let us say this is the tariff of the day. When should I charge the battery and when should I discharge the battery? So for this, first we need to understand that why this kind of a tariff is what we are studying. So let me start with tariff first. What do we mean by tariff is what is the cost of electricity that I am giving for every unit that I am consuming? What is the cost of electricity that I am paying for every unit of electricity that I am consuming? So usually what happens is in the current scenario, what we have is we usually have got a block rate tariff in our house. For the first 200 units, you will be paying some amount. Then for the next 200 units, you will be paying some amount. Then the next 200 units, you will be paying another amount per unit charge, per unit of electricity that you use. So let us say that suppose if I am paying 2 rupees per unit for the first 200 units. So when I consume 200 units or below, whatever amount of electricity I am consuming, I'll pay the amount that is equal to number of units consumed multiplied by 2. Okay. So in case if I am I just take up a pointer to show it off. Suppose if I am using 180 units, so my bill will come out to be multiplied by 2, that is 360 is what I pay other than the charges. There are some other charges also, we are not talking about those charges right now. There are some fixed charges and some security deposits and I don't know what other there are so many charges which are there. But on the whole and whole, if I have used 180, then I should pay 360 plus some other tariff, whatever it. If I have used, suppose if I say, if I have used 220 units, now what happens is that for the first 200 units, I'll have to pay 200 into 2. And for the next 20 units, I'll have to pay 20 into, let us say the next block is for 3 rupees. So this is the cost that is equal to 460. So if you see here, the change is a little bit more. And I'll just go to another one more last example here. And suppose if I say that I have got like 550 units, suppose. So the first part would be 200 into 2, that is 400 rupees. Then again 200 into 2 into 3, sorry, this is 600 rupees. So this 600 is coming up for the next 200, and then the remaining that is there, see, 200 and 200 means 400. The remaining 150 into, let us say I have to pay 5 rupees here, or let us say 6 for a better calculation purpose, 6 rupees per unit. So I'll have to pay around 900 here, right? So the total bill that comes out is 1900. I believe this is understood. This is how the electricity bill is usually calculated. But this method of calculation of electric bill is not helpful, in the sense that our consumption pattern throughout the day is not, continuous. We change our consumption pattern. We consume more electricity during the evening, whereas we consume less electricity during the night. The fundamental is that we should have a straight load curve. The load curve should be a straight line, not a curved one. And this helps in economizing the, what we say, the generation of the electricity. So if I have got, if I can use 1 kilowatt throughout the day, that is good, rather than having variation in the load and the average being less than 1 kilowatt is not good for the generating utilities, right? And this is known to all those who are related to electrical. I believe everybody knows this part. So now the thing is, the variation to this, the variation which has been brought to this is that let us have a different tariff throughout the day. It is not based on the blocks, it is not based on the number of units that you are consuming, but you will be required to pay different amount of electric, the tariff, during the day itself. So if you see here, if I am in the morning phase, maybe I'll be paying somewhat around 2.2 here. Then it goes to 2.5, it increases. By 8 and 9 o'clock, it is quite high, and then it again goes down up to 2 p.m. So if I'm using electricity here at 2 p.m., I'll again be giving less amount of tariff. And then again, as we go towards the evening, the cost of electricity goes high. So if I am using 1 unit of electricity at 8 p.m., I'll be paying around 6 rupees per unit. Whereas if I use that same 1 unit at 2 p.m., I'll be paying approximately 2 rupees. Getting the point? So basically, the tariff will now, in this case, not be calculated based on how much of units you are consuming, but instead it would be when are you consuming it. If you are consuming it in the evening, you will be charged more. If you are consuming it during the morning hours, 7, 8, something, you will be charged around 5.5 or something like that. Getting it? So this kind of a tariff is in place in many countries, and this helps them to, you know, get a better load curve. People try to adjust their loads in the morning towards the afternoon or towards night, and even in the evening towards night or somewhere. All the equipments or load cannot be shifted. Like I cannot turn off the tube lights during evening. I will not shut off the TV in the evening, because that is the time when I can watch my TV. But what we can do is that the charging of the electric vehicle can be placed somewhere around at 11 p.m. or 12 p.m. in the night. We can change our using of washing machine from morning to afternoon if it is possible. We can shift the usage of the pump, water pump in our house from one position to the other position. So this will help me change my load pattern also, and this will also help the generating utilities to, you know, produce electricity in a more economical way. In fact, I'll just take a small deviation. Just see why this is also more so important in the coming days. India has aimed to have around 30% vehicles to be electric vehicles by 2030. So we need to supply electricity to charge these vehicles. And what will happen is that usually people will reach home in the same period of around 7, 8, 9 p.m. And then what would they do is they would go and plug in their vehicles. Just imagine 30% of the vehicles, you can count the number of vehicles which are there in your city, right? You can just get an idea about as to how many vehicles are there in your city and just see how much of consumption will it increase in the evening. One, and it's not like charging a mobile phone. Remember it. Electric vehicles are a big load, around 3 kilowatt, 4 kilowatt, something like that. So the point is that if everybody goes home and starts charging their electric vehicles in that period, how much of electricity will be generated in the night and how will they be able to supply? I believe you can empathize with the situation. So we need to have this kind of a tariff, and I believe we'll be having such kind of a tariff in days to come very soon. Now, if I do not have, let us get back to the paper. If I do not have a renewable system in my house, then the battery cannot be charged and discharged economically in that block rate tariff that I just showed. Because in that case, what will happen is when you are in that first 200 units, you are paying the same amount of tariff when you are charging, and when you are discharging, you are saving not the same amount, but you are actually saving lesser. So let me give an example. What happens is I was paying 2 rupees per unit. Just a second. Sorry. I was paying 2 rupees per unit, right? When I was charging my battery. So suppose if I say that I charged my battery by 1 unit. So how much did I pay for charging 2 into 1? Actually, I'll be taking a little bit more. So if my battery is at 1 kilowatt, because of charging efficiency being 0.98, I'll be requiring a little bit more electricity. So let us say I used 1.1 unit just for the sake of understanding. So how much did I pay? 2.2 rupees for charging of the battery. Now when I discharged it, acha, one more very important thing is even though I have used 1.1 unit, the charge on the battery is 1 unit only. I used more. Now what happens is that when I discharge the battery for supplying load at my house, what will happen is I will be saving this much amount. So how much do I save is 2 into, obviously 1 kilowatt was there, but I will not be able to realize 1 kilowatt. Let us say I realize 0.9 kilowatt. So how much do I save is 1.8. If I subtract it, what do I get is zero point 0.4. Now this is not saving but an extra bill that I'm paying. When I charge it, I pay 2.2, but when I discharge it, I am able to save 1.8 rupees only. Now what happens is in our house we are basically using the battery in a passive way, and we do not have a choice because there is no variation in the charges throughout the day. So the point is that without variation in the tariff, I will not be able to save the money. Let me give you another example for the same thing. When I charge the battery, when the if the tariff is varying, right? We just saw the graph there. So the tariff is varying. So when I charge the battery, let us say I charged it when the cost, the tariff was 2 rupees. So I said 2 into 1.1. I have paid 2.2 rupees to charge the battery. But when I discharge the battery in the evening, I'll again repeat, I'm discharging the battery in the evening. So what happens is the cost of the units at that time was 6 rupees. And going by the same values as I have used here, 0.9, I get it as 5.4. And this is negative. So that means that I have been able to save 3.2 rupees. The same scenario on this side, left hand side and right hand side. But what has happened is that on the right hand side, the tariff is changing throughout the day. I charged my battery during the night when the tariff cost was 2 rupees, and I discharged it in the evening when the tariff cost was 6 rupees. So obviously I'm saving the money. So I believe you understood the part that the battery charging and discharging can only be beneficial when the tariff changes throughout the day. Without variation, the operation of the battery will actually result in a loss, which is shown here, right? So that is why what we had seen here was. One second,
Hello, Dr. Altaf.
yes, sir. Yes, sir.
It means that discharging anyway, it is not in our control, right? So,
No, we have to control it. That is what we are saying. We have to control it.
but if the vehicle is charged and you want to like anyhow, you have to utilize the vehicle at certain point of time, not at the evening or not at the morning. So,
Yes, what has happened is nowadays there is a new concept. There are three new concepts which have come in. One is smart home energy management system, in
mhm,
which you will have a centralized control of your usage, and through this you can control it automatically. Even though you will come and plug in your electric vehicle, it will not start charging until and unless the tariff rate has gone below a certain value.
okay.
And similarly, your pump will also not work. So this will automatically be taken care of by the centralized system,
Mhm.
right? So this is already there in research, and there are now smart plugs which are coming in. In fact, in India also now this smart plug concept has come in. There are companies which are manufacturing smart plugs in
Mhm.
which you can plug it, but it will not charge at that time. You
Yeah.
can program it to start charging at a particular specific time. So that can always be done.
Okay.
But the concept and the technology is yet to come in. In India, we will require some time for this to actually be visible on the ground.
Mhm.
In fact, the deregulation itself has not happened. So we are still paying in block rate. Let us wait for some years. We'll, by 2025, I expect the energy markets would be deregulated fully. And then you will have a choice to buy from where, and then in that case you will be asked to, go through. If you go, Vishnu, I'll suggest, if you go through some of the websites of energy trading in US, there
Mm.
are some companies who pay you to reduce your consumption. Actually,
Oh, okay.
yesterday also I missed out this thing. There are several different concepts now coming in. Yeah, you can put your question, then I'll go ahead.
Okay. Fine.
So there are several different concepts which are coming in, like virtual power plants is there. There is a company called as Statcraft who has started operations in India. They are not into virtual power plants in India, but in Europe and other countries they do operate in this particular technology. And then there is a concept of VESS also, virtual energy storage system. So there are so many things which are coming in.
Yeah.
But all these things will be beneficial with the deregulation only. You cannot just jump into it without saying, and we need to have smart meters and all of it in place. Without that, it may not happen.
Okay.
So, right. So let me just move ahead with this slide now. There are three different kinds of tariff which are there. Usually, day ahead and time of use are classified as the same thing. And I have already given you an explanation on this thing as to how we do pay the electricity. Now, what happens is that again, there is a difference between the first two and the third one. In real time pricing, the cost of electricity changes every 15 minutes. Nowadays, they are proposing for 6 minutes also. So, the cost of electricity changes every 15 minutes in India. We do not feel the changes, but there are changes on the ground. So, every 15 minutes, the cost of electricity changes. In day ahead, what happens is that we provide some slabs. So the electricity will change only on those slab rates only. It will not have any random rates. But in real time pricing, you can have different kinds of pricing. It can vary by a lot itself. So now in the previous slide, what we saw here, this is an example of real time pricing. This is an example of day ahead pricing. So I have 2, right? So it is either 2 or 3 or 5. No other value is there. There are 3 values only which are there. You can have more values also, but like just for an example, I've just shown it here. So I've got say tariff rate of 2222 and then suddenly it jumps to 3, then it retains at 3, then it goes to 5, retains at 5, goes down to 3, 2, 3, 3, and so on, 5, 5, 3, 3, 2, like that. So this is also one way of representing the tariff. Now the fundamental is that by using my battery efficiently, I want to reduce my energy bills. This will, I'll tell you, no matter how many algorithms you apply and all of it, but uh, this will not be possible right now in the given situation, but it may happen in the days to come. So my objective is to reduce the energy bills, and for this I want to maximize the BESS, that is battery energy storage system utilization, for a given efficiency. Whatever I have, I want to optimize it. So here the objective function is the summation of CL plus CB, where CL is the cost of energy used to supply the load, whatever load I have in my house, and CB is the cost of energy required for charging of the battery. So if I discharge it, then CB will be negative. If I charge it, uh, I'll be the CB value would be positive. And my concept is, or my objective is, to minimize the value of OF. Objective function requires to be reduced. So
Excuse me.
yeah, yeah, yes.
Altaf, can you tell me that what is a CL and CB?
CL is the cost of energy, which is there for the load only, my house load.
Consumption, sir?
Consumption, my consumption without the battery. And
Okay.
CB is for charging and discharging of the battery. So if I charge the battery, the value of CB will be positive. But if the battery is supplying the load, then in that case, the value of CB would be negative. So that will help me reduce the
Thank
costing.
you, sir.
Right. So we will see. There are some more slides, I think, so that then the concept would be very much clear. So how do we find the cost? Here is very simple: load into the tariff at that time. CL is equals to tariff into the load. So if the load is known and the tariff is also considered to be known, then CL can easily be found out. So CL is not an issue for me. I know the load and I know the tariff. I can multiply it and I can find the CL. This is under normal conditions. But how about CB? How do I find out CB? So this, if you just observe, what I'm trying to do is, let us go for a reverse engineering, because this is my OF, objective function. I need to find out the value of CL and CB. So CL is very simple, load into tariff. Fine. So I know the load, I know the tariff, I know the CL. Now what I want to do is, this load I am not going to change. We are not into load management right now. So I'm not changing the load. And what I need to do is, I need to optimize the charging and discharging of the battery so that CB will help me reduce the total costing. Okay. So for this, I would be requiring the round efficiency, charging efficiency, discharging efficiency, charging rate, discharging rate, and many other things. So either we can guess those values or we can take it from the paper. So let us take it from the paper. Now, what are the assumptions before we go for it? This is also a very important part. While reading a paper, I just missed that part out. What are the assumptions? Assumptions are really very important in the paper. So the assumption is that the tariff rate for the day is given to me. Okay, and the battery round efficiency is also known. So now let us move ahead with the actual concept, because if I leave this to you, you will not be able to solve the paper today itself. Now, when does the battery charge and when does the battery discharge based on the efficiency? So what we have done is we have created some conditions here, and in this you will find one term called as NEPP. This is normalized electricity purchase price. See, the price will vary here and there, right? It may be 2 rupees today, tomorrow it may be 5 rupees, day after tomorrow it may be 10 rupees, and so on and so forth. So what we do is we take the maximum value of the day and divide the tariff of the whole day by that value. Then the values will come up in a normalized way. So that is called as NEPP, right? If you want, I'll again repeat it if there is anything required. So NEPP is the normalized electricity purchase price, and how do we get it is we divide the whole day tariff by the maximum value. So it will be divided into different parts, and that is how we go. So now what happens is that when we divide it, we have assumed it as a day ahead market with three different kinds of prices. The lowest price of tariff is called as off peak, right? The middle one is called as intermediate, and the highest price is called as peak. So what we have said is that this is that the condition one will be satisfied when we say that any PP, that is off peak, and the ratio of NEPP off peak and intermediate, in between these two values lies the NB. NB, eta B, sorry. Eta B denotes the round efficiency of the battery. So this will actually help us to understand when the battery should charge and discharge. This was already derived in an earlier paper. I've just quoted it here. Then this is the second condition, right? And this is the third condition. So off peak by intermediate ratio, and intermediate and peak ratio, if round efficiency lies in between it, we say it is condition 2. If the intermediate value is less than the round efficiency, we say it is condition 3. So this is only a marker that we need to find out before we go into the actual charging and discharging pattern of the battery. I'll come back to this slide if and when required. Right now, you just understand that we are trying to give some conditions to the system. And now, based on the condition, what we do is we decide when the battery should charge or discharge, right? So if it is off peak, no matter which condition we are in, we are going to charge the battery. If we are in the peak tariff time, we'll try to discharge the battery. And this discharging is not only for the load. Remember, I'll just put in this point very clearly. This discharging of the battery is not only for the load, but we will also sell electricity to the grid through the battery. We want to earn money also as well. So this peak, whenever the peak tariff comes in, I'm going to discharge. But in intermediate, there is a variation which happens. If we are in condition 1, we are not going to charge, we are not going to discharge also. The battery remains as it is without change. In condition 2, if the system lies in condition 2, I will discharge the battery only during the intermediate period. And in condition 3, I can charge as well as discharge the system, the battery. Right? So remember this, and as and when required, I'll just come back to the slides whenever you require it. Or otherwise, at least for those students who are looking for grades, I would say that you at least take down these things, because it will be required when you go for your, what we say, flow chart and all of it. Now, the data. I'll just stop here, and now I would ask you all, if somebody is interested to answer me, what all different kinds of data would be required according to what I have given and what you have understood. Just let me know what different kinds of data would be required to proceed for this simulation. Anybody?
think, Dr. Also, we required a round of efficiency or a charging efficiency and discharging efficiency so that we can calculate round efficiency
Very correct. Very
and
correct.
tariff rates for 24
Right.
hours.
Right.
Think
Okay. You hit around 60% of the thing you have hit correctly. Now see why
So
I
you
asked
will
this.
require the load profile also, how
Right.
the
Right.
house load is changing.
Right. Very good. Very good. So one and two things, two, three things are still pending. The point is, even after explanation, see what my thought process was to also engage the PhD scholars here who have just joined in and would be going for deciding their topic. See, paper reading a research article and implementing it is a very tough task because of this only, the input data. Even after going through all the topics, we have been able to hit only 60% of the input data which is required. So let me just now list it out. First one is charging and discharging efficiency. That was obviously taken up. So in this case, we will be taking charging and discharging efficiency as 0.98 and 0.95 respectively. So charging efficiency is 0.98. Discharging efficiency will take it as 0.95. This is only for the understanding part, and if somebody is interested and is going to go for the hand calculation as well. As Saidulu sir mentioned yesterday, hand calculations are very important. So with this charging and discharging efficiency, I'll also be able to find out the round efficiency. So charging efficiency is 0.98, discharging efficiency is 0.95. I get the round efficiency as 0.931 by multiplying both of them. I just try and here. Charging efficiency, I have taken it as 0.98. Discharging efficiency, I have taken it as 0.95. I multiply both of them and I get round efficiency as 0.931. Sorry, 931. Now, I did talk about this thing also, but it went over, means you forgot this thing probably. SOC min and SOC max. What is the limit of the battery? What is the minimum limit? What is the maximum limit? So we are going to discharge it. SOC min will be taking it as 0.2 and SOC max we will be taking it as 0.9. So it will go down to the 20%. It will discharge up to 20% of the maximum capacity, and it will charge up to 90% of the maximum capacity. Then the next thing is battery capacity. What is the capacity of the battery? Without this, we will not be able to relate the load and the tariff. This I did not uh, explain, but if you just saw the assumption also, I think so. Anyway, so we are taking 3 kilowatt hour, 3 kilowatt hour as the battery capacity here. So SOC min would be 3 into 0.2, that is 0.6, and SOC max would be 0.9 into 3, that would be 2.7. You are not going to cross this limits. And then charging and discharging rate, this we are going to take it as, I'll just write it down here. So SOC min, we are taking it as 0.2. SOC max, we are taking it as 0.9. Battery capacity 3. And charging and discharging rate, we are taking it as 0.75 and 2.25. That means it will take 4 hours for the battery to fully charge. If I say 0.75, it clearly means it will be able to charge 0.5 kilowatt per hour only. And that means it will take 4 hours for the battery to charge fully. Okay? And then obviously I'll be requiring load and the tariff. Right? So this we'll see in the coming slides. So as far as the tariff is considered, this is the tariff that we are going to have. I have already put it as NEPP. We are not going into the actual values. So from morning 1 to 8, there are 24 hours that we have listed. We can say evening 11 to morning 8, the price will be 0.78, that is off peak. Afternoon 1 o'clock to 4 o'clock 0.9, and the remaining time it will be 1. Okay, so now we know whether it is going to be in the when will we be paying more and when we will be paying less. And then let me just go with this thing. This is my load. This red line is not the load. Huh? Red line is not the load. The load is the blue line. You can just go through the paper also. You will find the same blue line. Now just assume that I'm not there. I'm not there. And how do you get the value of the load for the day? So right now we'll not go into the details of it, but there are some softwares which with which you can actually use it to convert the graph into the values. So let us just decode the graph and let us just move the line a little bit here and there and see as to how the values are going to come in. So I've just moved it a little bit here and there. I can just, whenever it goes through a particular line, I can stop it and I can check what the values are. If I just move a line like this, I'll be able to get the values for all the 24 hours based on the scaling. Let us assume these are the values. Let us assume these are the values. If you just match it, it is quite similar to that. I have taken 1.12 in the first hour. Second hour, it goes to 1.09, 1.08, then 1.09, 1.1, right? And so on and so forth. It, around at 5 p.m., it has reached 1.8, then again 1.78, and it goes down. And at the 24th hour, I say it is 1.27. So these are the values that I am going to take for the load. Okay. Now, in the actual paper, I have varied it for all these things, but let us not go into the detail of it. I have experimented for all these things, but we'll just experiment it for the values that we are going to take. Now, first of all, I'll again stop here and now you tell me, how do I calculate CL? How do I calculate CB? And is there anything else that I need to calculate? Today is the tutorial, so you need to unmute and you have to speak as well. This is an interactive session from now for the next 1 hour. So I want you also to contribute into solving of the paper. We have got everything that would have been available as such. Now I want you to tell me what is to be done next. I know the, just see here, I know the tariff, I know the load, I have got all the details here, right? So now what should I do? See, load is given to me, tariff is given to me, I've got all the other values as well. Now what should I do? Just think over it. It's not a, I'm not putting a gun on you. I'll give you 5 minutes, think over it. Let us, I'll again ask the next question at maybe 3:40 somewhere or 3:40, 3:38 somewhere. I'll ask you the next question. What should I do? I want to solve the problem for the given values.
The load curve, actually, we can calculate CL.
I'll get back to you. You think over it. I'll give you 4 to 5 minutes. Then again, I'll come back to you, right? And then we'll go step by. Actually, I want step by step. What exactly are you going to do now? What is your first step? What is your second step? Third step? And how do you move ahead? I'll get back in 5 to 6 minutes. So now these are the things that you can do to show that you have understood. Either you can do a hand calculation, design an algorithm or flowchart to solve this problem. You can show the charging and discharging arcs for the going to charge and discharge. You can find the objective function.
Sir, your voice is breaking continuously.
Yes, now am I audible? Am I audible?
Sir, your You're audible, but your voice is not clear, sir.
Still not clear.
It is breaking a little bit.
Yes. Now am I audible? Am I?
Sir, you're audible, sir. You are audible, sir.
Yeah, just one second. Now is it okay?
There is some echo, sir, but you are audible.
Yes, sir, audible.
I have actually joined through two devices now. Oh my God! So I'm coughing twice. Okay. So now we'll be going into these things. What I want you to do is any one of them at least. Either you do a hand calculation, design an algorithm or flowchart to solve the problem, show the charging and discharging hours for the battery, and find total objective function value, and write a program for the given problem if possible. Right? So now tell me what are you going to do first? Anybody? Is anyone? I'm audible, right?
Yes, sir.
Now, anybody can please tell me what could we be doing first? Just randomly, and it may be wrong also. It's not compulsory that you should be correct.
So the first CL to be calculated, I think this is the first thing we can do it easy way.
Good, very good. So you know the. Just go back here.
Tariff of CL.
But Vishnu, this is a temporary solution. You are running away from the main one. But anyway, let us say this is your load. You just randomly write down something and multiply it with the tariff.
Right.
This is the tariff. This is the tariff. So 0.78, 0.91. The hours are given, and let us say this is the tariff. And you can come back with the CL. Fine. After that, what? Means I can do this thing in Excel. What I can do is I can take the values here of the load multiplied by the tariff and get the CL.
Yes.
After that, what should I do?
We should find the charging and discharging of the battery since we have the tariff, so we know what are the off-peak periods, intermediate period, and the peak period. So, like,
Yeah,
we
but
can find based on the state of charge of the battery.
when does it charge and when does it discharge? Getting my question?
Sir, I think we need to
Yeah.
design an algorithm first to find out the charge and discharge and everything.
Okay, so now what we are doing is let Let's take max of 10 minutes because now I did not share my screen continuously. If some data is required, just tell me. I'll go to that slide. But that would help you get the CL first. As Vishnu said, let us find CL first. Okay, and then let us move ahead.
First
By that
CB
time,
or
I'll open an
conditions
Excel
we can check, or
Pardon?
conditions, condition 1, condition 2, condition 3. For CB first, which condition we can operate, that can be checked easily.
Yes, that is the first thing that you need to do actually.
Yes. So condition 3 is most satisfied.
Yeah, right. I'll go for that also. Let us first take 5 to 10 minutes and find out the CL.
Yeah.
I would like everyone to do the same thing. So what I have done here, I have taken the load, tariff, and multiplied it. This is CL. CL, I found the sum here. Okay. Why CL was introduced was one of the reasons is it got demand response. Then in that case, we'll have this CL also changing. Just one second. Now I believe the echo is not there. So now tell me, as Vishnu pointed out, that we need to find the condition also. Condition is coming out to 3. In this case, just stop sharing this file, shift it to the PPT. You can just have a look there as to why we said it is condition 3. Right, so this is the just one second. This is the condition, and in which we see that NEPP here is 0.9. NEPP of peak is 0.75. Intermediate is 0.9 and peak is 1. So you can just find out which condition is satisfied, and probably it comes out to be condition 3. All right, just check it out.
Can you go to the table, sir?
Okay, now that we know it is condition 3, this is how we go ahead. So for condition 3, I can charge as well as discharge. Now, what I want you to do is, yes.
So can you go to the table where we are able to see the NE? Just a minute.
Yes, sir.
NEPP, sir. 0.7 point.
Okay, this one.
So charging rate.
No, I'm not getting it.
From where we extract this data, no? Sir, that table,
One,
sir.
this one.
Table, sir. Next to table we have.
I think she's asking peak, intermediate, off peak. It's
This one,
NEPP
sir, this
rates. Yeah, this one.
This one.
Table. I just want. Thank you, sir.
Now, can anybody do the calculation for the battery? And we need to get any one out of these. Can I shift now?
Yes, sir. Thank you, sir.
This you want?
Thank you,
You
sir.
can generate your,
I
you
note that
can
down.
generate
Thank you.
your own load. No issues.
You can go back to the Excel, I think. So.
No, now I'm not going to solve it. It is for you to solve it.
Yeah, yeah.
And
So
I'm
cycle is
going
like,
to stay with this slide now.
I think as
You
per
want to say
condition 3, that
it's charging this cell, but Vishnu, see, if everybody does it on its own, it would be more
yes,
preferable. Why?
yeah,
Why
yeah.
is there would be some mistakes probably, some things
Mm.
that you won't consider. That is why let me stick with this slide and you try to solve it. I'll stop sharing whenever you say that you are ready. I'll let you share it. Everybody is open. They can do hand calculation. They can do flow chart or third or fourth combined. Fifth, I don't think is a possibility in the given time. I'll be waiting for somebody to just tell me that he or she has finished. I'll hand over the screen to them. I'm sorry to disturb your calculations, but this is the most dangerous part, battery charging and discharging. And remember one thing, whatever calculations you are doing is for condition 3 only. But when you actually write the whole program, you have to write it for condition 1 and 2 also in that.
Dr. Altaf, can I share? I'm not sure.
Yeah, just 1 second. Thank you. Yeah, please start.
Just
Share
can I
it.
share? I'm not sure whether I'm correct or wrong. Uh, just
Let us have
I'll
a look,
share.
sir. Even I'm not sure whether the answer that I gave would 100%, right?
Your voice is low. Are you
Okay.
able to see my screen?
Yes, yes, yes.
See, it's a battery charging and discharging one.
Yeah.
The yellows is a peak, okay,
Mhm.
and green is intermediate, and this is off peak, white one.
Okay.
Just I tried it. It comes around positive 11.71 rupees. Something.
Mm-hmm. So can you just explain it a little bit?
Yeah, because condition 3 is satisfied. So 1 to 8 period I have taken a charging.
Yes.
Okay, charging is in the cycle of 0.75 kilowatt hour,
Right.
and 13 to 16 again a charging and discharging. But if you go to the cycle 9 to 12, it started discharging it, and then for 13 to 16 I have to go for charging only here.
Okay.
Yes.
No,
Again,
what is
17 to 22. Sorry, it's a discharge. Yes, sir.
so can you explain G column G
This one,
and yeah.
G is the price I have taken it. Like it's a
I think you
intermediate.
multiplied it with
It's
multiplied
a
it.
price, yeah.
Okay. Okay.
NEPP price, yes.
Okay.
It's a multiplied one. So it
Yeah.
is 23.75, and this peak is this. So
Mhm.
this is a minus. It's
Okay.
coming like this.
Anybody else?
I'm just stopping my
So that is the chart. The
screen.
chart is
Yeah, it's a cyclist for the charge and discharge in the 24 hours. Yeah.
okay. Okay. Thank you, sir. Anybody else?
Yeah. Thank you.
Sir, do you think there is some fault in your calculation?
Hello.
Yeah. Do you think there is some fault in your calculation?
I hope so. One after discharging to 0.75, because my SOC minimum is 0.6, so I cannot go below of that. So I stopped at 0.75.
Yeah. No, but why 0.75? Why not go to 0.6?
Yeah, that I kept constant there. 0.75. Yes, you're right. I can go up to 0.6 also, right?
Okay. Anybody else? Arpita, Fabia, are you trying or not? Vijay?
Trying it, sir.
Okay, so if nobody should I wait or should we move ahead? And let me tell you, this is only the tip of the iceberg. You require a lot of study into that to actually perfect it. Okay, so I assume that if anybody is doing it, please let me know. So I'll wait for them. Else, actually, my thought was that I would be getting the answer. Vishnu, you were quite close to it, but you did not consider one very important thing.
Mhm.
What about the charging and discharging efficiency?
Okay. Okay.
In your calculation, that was not there.
Yes, yes, it's not multiplied. Yes, you're right. Yeah.
That is. So I'll just share because we are also towards the end of the class. I hope it was helpful for you all and you at least ventured into something new. It's
Yes.
not important that you solve it or not, but you understand it along with its complexities. Vishnu, you'll have to stop sharing. So, share. Yeah, thank you.
I want to share it or
Yeah, I'm sharing.
no? I'm not hearing you.
No, no,
Okay.
I requested you to stop sharing.
Okay. No.
So now this is what I had done. Vishnu, can you just share what all different columns you added here?
I've added battery charging and discharging one.
So that was
Kilowatt.
a charge on the battery.
Yes.
The next column was
Next column was means charge and discharge. I put it in different ones depending on the intermediate and peak hours. Okay. And the
we
next
divided both
column
in your head.
was N NEPP rate. Anyway, it is there in this. Yeah.
Okay, so I'll
After that,
change it a
multiplication.
little bit here.
Yeah.
What I thought how the calculation should be, because in Excel I haven't uh, got it for the class, but I just created it now. So what I did was I added SOC first, and I assumed that we start with 0.2 first, and in every hour in which we can charge, like Vishnu had colored it, I'll just color it here. This is your off peak. This is your intermediate. Okay. Intermediate is blue, peak is white, off peak is yellow. What I did was I took it as SOC. Now it can charge by 0.75. SOC limits are there, so this is SOC min. And it can charge by 0.75. So this 0.75, if I just divide it by 3, that is 0.25. So SOC can increase by 0.25 only every hour, not more than that. So what I did was I have increased it. We'll just concentrate on SOC right now. 0.25, 0.25, then I don't have an option. I increase it by 0.2. Right? On the other hand, when it discharges, it is 2.25. I divide it by 3, I get it as 0.75. But actually, if you see, the maximum range is 0.9 to 0.2, that is 0.7 only. So what I can do here is I can move down to 0.2 directly. Then I retain it again till I go into intermediate, charge it and again discharge it. Again, I maintain it. Why I have kept this thing as red is because this off peak is also there. So this charging would have already been there. So actually for the next hour, I should start with 0.7, not 0.5. Sorry, 0.2. That is why I just skip this thing. This is not required right now. Until unless I go for a 48-hour calculation, then the last 24-hour calculation would be correct. That is. So I'll repeat this thing again. Now, what is the energy used? So if you just see here, this is my formula. So what I've done is I've taken 0.25, that is the change in SOC, multiplied by 3, that is the capacity of the battery, and I divided by the charging efficiency, that is 0.98. So this is the energy used for charging the battery in these 3 hours. It gets discharged in 1 hour, and this calculation in this I have multiplied it by 0.95, not divided by. So this is discharging efficiency. And I have taken it as negative because I am basically saving that much of money. And then again, the same cycle repeats here. Okay, charging, discharging. And this I have just put it as red. I'm not doing the calculation. So for CB, then what I do is I multiply the energy used multiplied by the tariff. This is how I get it. So this is the costing. And this is how I, to be very frank, I'm able to save only 0.19. But if we go by it, this is the NEPP that we are talking about. So when I multiply it, I will get a bigger value there. And this is the saving for 1 day. Over a period of 365 days, I will be saving a lot more. Right? If there are any questions, I will take it. And for those who have registered for grading, I would say that you please repeat the same thing and send it to me with a round efficiency of 0.85. So your charging and discharging would be a little bit different than that. This would help us, provide a grade for you all. This is only
Can
for
you
those
please
students
repeat
who
that
have
CB?
registered for grading, not for faculty, not for faculty.
Can
You
you
want me
please
to
repeat
repeat?
CB, sir?
Can you just repeat, please?
No, the CB column, can you please repeat?
In CB, what I have done is, this is the energy used. I have multiplied it with the tariff. So this is the value that I get. F3 into C3. F3 is the energy used by the battery. This is the tariff. Is it okay?
I just have a request, sir. That is class if possible. Share today's PPT, sir. So that
Unable
I'm
to
working
hear you.
that I can try. Am I audible, sir?
Yeah, audible.
Just a request. Today's PowerPoint presentation material kindly share today so that I am on halfway of the
My
work. I'll just try, sir. It's out of interest I'm doing.
yes.
Okay. Thank you, sir.
You want me to share the PPT, no?
Yeah. The lecture material, today's material you share, sir. Tomorrow during
Sure.
free time I will sit and do, sir.
Okay, sure. I'll share. So thank you all. If there are any questions, I'll take it. But let me make this thing clear. Again, this is just an introduction. You need to put in forecasting of the load and many other things to get it accurate. It's not that easy. But the thing is like this is just a, to increase your interest into that topic. Right, so that should be all for today. Tomorrow again we'll have the session at 1 p.m. I haven't got the schedule from Professor Jangir, but as soon as I get it, I've asked him. I'll share it with you.
Thank you.
Thank you.
Thank you.
Thanks.